And it is recording. All right, here we go. Exercise 3C. This exercise is really you can summarize as solving quadratic equations, but you can't solve unless you factorize. Okay, so 3B was factorize, 3A was expand and simplify. So 3B, I taught you difference of perfect squares, how you can factorize, and at the same time, I also taught you how to factorize using cross method. Okay, those two skills you must be very proficient, especially cross method. Here today, we're going to do exactly the same thing, except we're just adding on one extra theory. It's called the null factor law. Let's see if you remember what it is. Null factor law says if A times B equals 0, what do we know? Hands up if you know what the law says. Milena. Very good. A equals 0 or B equals 0. Fill that in. The logic is very simple. I mean, you can probably do it back in primary school as well. Here's a logical example. If I gave a primary school student, I said, magic box times 3 equals 0, most students would know that the magic box must have 0. We know that 0 times 3 has to be 0. And then if I ask them, well, okay, you're so smart, you know that this has to be 0 in order to make that equal to 0. What if I change that 3 into a magic triangle? So if you had magic square times magic triangle and the answer is 0, what can you deduce from that statement? Lucky. One of them equals 0, logically. So this could have been 0, and it doesn't matter what this number is, because 0 times that will always give you 0. Or it could have been, doesn't matter what this number is, this could have been 0, and therefore the entire thing would be 0. Okay, that's literally what null factor law is saying. Instead of using magic square and magic triangle, they're using A's and B's. Same idea. Okay, so that's why we're saying, well, if A times B, even though I don't know the numbers, but I know the result 0, well, one of them has to be 0. The reason why you need to know this, could be 0. Let's go right here, could be 0, and magic square could be 0. The reason why you need to understand this idea, it's a very simple idea, is that when you factorize, what you may not have realized is that you're actually doing the same thing. You're saying when you get into two brackets, it's something times something. Because right now, I just don't know what x plus 2 is. But if I knew what x was, this would be a number. So hypothetically, if I said if x was equal to 1, well then in this bracket here, this would have been 1 plus 2, and this would have been 1 plus 1. That would have gave you 3 times 2, and it would give you an answer, clearly not 0. So what you really have here, even though it doesn't look like two numbers multiplied to each other, it actually is. That's why you need to be able to factorize first. No matter what quadratic equation they give you in 3B, you need to be able to factorize. Because if you can factorize, then you can use null factor law. The logic is that one of these brackets have to equal to 0. So, by that logic, let's solve for it. So once you factorize, if this could be 0, or maybe this could be 0, we don't know which one, so let's solve for it. If it was x plus 2, if it was x plus 2 was meant to equal to 0, then what would x have to be in order for that to equal to 0? This is where you go back to year 7 mathematics and you do inverse operations. Something add 2 gives you 0, and the logic is, what would you add 2 to make 0, Kai? Yeah. Something plus 2 gives you 0. What would that something be? You're sure? Someone else? Minus 2. And one of the things is if you want to solve for x, right here, that's plus 2. We can say opposite of plus 2 is minus 2. 2 take away 2 cancels out. And what you get is x is equal to negative 2. So that's one possible answer, that if I put negative 2 here, that would be 0 times something, which equals 0. Okay, that's why we do that technique back in year 9 and year 10. So here I'm going to do it again. What if it wasn't this bracket that was meant to equal to 0? What if it was the second one? What if it was x plus 1 that was meant to equal to 0? Same logic again. What would x have to equal to? Let's go with Sion. How would I solve for x here? Very good. Again, that's a plus 1. So if I minus 1 on both sides, balance in the equation, 1 take away 1 cancels out. I get x is equal to 0 take away 1, negative 1. These are both two possible answers that if you put it back into the brackets, the result should be 0. You can test it. If you sub -1 in, -1 plus 1 will be 0, and then -1 plus 2 is 1, but 1 times 0 is definitely 0. That's what you're trying to say. You're saying there's two possibilities that if you sub one of these numbers into that statement, it should equal 0. Yes, Molly? The answer should be x equals 2 or x equals -1. The working out, this is the first steps there. Okay, as you get through, especially year 11, we no longer do this anymore. We just get straight to the answer. But I know that from year 9, year 10, a lot of students memorize the how to do. They don't actually know why it works. And so they often just think if it's x plus 2, they do the opposite of that sign. So if it's plus 2, they write -2. If it's plus 1, they write the answer is -1. Problem to it is if I give them this in the test and I say solve it, they may get that wrong. So they get confused because they're used to just looking at the pattern rather than understanding what null factor law really was. Okay, so that's how I know if a student totally understands it or they don't. Okay, so I'll give a variety of that. I give you a median question, and then I do this just to see if students get how to solve it. Okay, so if you did what I just taught you, you should end up with x equals 3 on 2, and that one should be x equals 3. Okay? All right, here we go. Now, so that's the theory for today. So you're just applying that logic. First things you have to factorize. So I gave you 4 different examples to practice factorizing. The back of the page is applications. Okay, so you're just applying your thinking, just something slightly different. But let's go with the first one. So this one, I like to give this to students in a test because if they're just familiar with the sign, this is where I will catch them. This x here, I know it doesn't have a bracket, and that's for some reason it trips students over, and they're like, oh, what do I do when it's just x by itself? It's the same thing. If you know how to do the one with the brackets, you should know how to do it without the brackets. Same idea. See, what this really means is it's x times x minus 3 times 2x minus 3 has to equal to 0. Now, based on the logic, you could have looked at it as magic square times magic triangle times magic circle has to equal to 0. What would you be able to determine from this logic? Well, one of these have to equal 0 to make that equal to 0. True? Okay, so 0 times something, one of them has to be 0. We just don't know which one. So because we don't know which one, we solve for each one. We say, all right, well, what if it was this one? What if that was meant to equal to 0? Well, then you're done. There's nothing else to solve. X equals 0. So this is one answer. But funny enough, when I put that in a test, most students don't know what to do with the x there. That's one answer. X could be 0. 0 times this entire thing should be 0. Makes the statement true. Next one. What if it was this one? What if this entire number needs to be 0? Well, x minus 3, what would x have to be? Something take away 3 gives you 0. What would the logic be? X has to equal to 3. So most students do this in the textbook, they'll get this one right. They may get this one wrong, even though technically that's meant to be pretty easy, right? And then, this is how I know if they truly understand it. So the third one, same thing. Maybe it wasn't the first one, maybe it wasn't the second one, maybe it's the third one. If this was meant to equal to 0, well then let's do some calculations here. 2x minus 3 was meant to equal to 0. We're trying to solve for x. X needs to be something that you double it and then you subtract 3 to give you 0. Here you balance the equation, what you did in year 7. Balance the equations, opposite of minus 3. Add 3 on both sides. -3 plus 3 cancels out because they're opposites. 2x is equal to 0 plus 3 is 3. And I'm trying to solve for x. So I got to get rid of that times 2. Opposite of times 2 is divide 2. So here I say divide 2, and your answer is 3 over 2. Those are my 3 possible answers for the 3 terms that you're multiplying to. X times this bracket times that bracket. But you couldn't have done this without factorizing first. Okay, so you need them all multiplying to each other. So that's one nice example of how. So I'm just going to circle this and make it a bit smaller to fit into the box there. There's one nice example. What's another one I like to test my students? Because they're so used to seeing x minus, I don't know, x plus b and then x plus c equals to 0, and they just write in the answer from year 9, year 10, I like to switch it around. I might give them something like this now. So they don't get the 2 brackets, and I'm like, all right, so what do you do? How do you solve for x? One of the common mistakes, so don't copy this part down, one of the common mistakes that students do is they do this, divide x on both sides, x divided by x cancels out, x squared divided by x cancels out, and they say x equals 2. One of the biggest common mistakes. Okay, and the reason why this doesn't work, it's a bit more conceptual. You're assuming that x cannot be 0. Okay, because you're saying, I can do x divided by x, but what if x was equal to 0? There's a problem. You can't do 0 divided by 0, and you can't do 0 squared divided by 0. Try that on a calculator, and it'll tell you cannot divide by 0. Okay, that's one of the deeper thinkings that you'll have to do at year 12. So how do you solve this problem then if you can't just divide x's on both sides? Well, the only way that we know is you have to combine them together on one side. So here, this is what you should copy down. Minus 2x on both sides. 2x take away 2x cancels out. You get 0 on one side. On the other side, well, you have x squared minus 2x. You can't group them together because they're different terms. One's an x squared and one's an x. But here, you can factorize what you did back in exercise 3b. If I were to factorize it, what's common about the 2 terms? What's common about x squared and minus 2x? X. Take out the x as a common factor. X times what will give you x squared, and then x times what will give you minus 2x. And hopefully you figured out it's x minus 2. And you're back to what I showed you in the first example. But again, sometimes students look at this x and they're like, what do I do? They know how to do the one in the brackets. And they're like, I don't know what to do there. So here, same idea. It could be, this could be 0, so x it could be 0. Or maybe x minus 2 could be 0. Solving for it gives you x equals 2. So you weren't wrong before, you were partially wrong. If you divide x's on both sides, you neglect that x could be 0. You're neglecting the fact that that was a possible solution and you only got half of it right. Okay, so the proper technique is that you're meant to move all the x's to one side, factorize it, then you solve it from here. Okay? So that's a second typical mistake that students get. And then now the last 2 is what I taught you yesterday. You need to be masters of this. So in year 10 with my classes, I drilled in these exercises over and over. I had to make sure that my year 10s, when they walk into year 11 methods, if they chose it, they had to know how to do this. Okay, so this is one of the most important skills. You need to be able to factorize quadratic trinomials. Okay, and even if you can't at this moment, that's okay. One of the students that I might have told you the story who struggled with mathematics or maths methods for 6 months of the year, he was getting, 15, 20% throughout. That student had never known how to factorize, but he spent 6 months to learn this as he's failing unit 1, right? Unit 2, once you've learnt the skill, everything else starts to fall in. Your algebra improves, your graphing improves, and unit 2 in the exam, he got an 80%. Okay, so that student eventually moved into year 12, carried on, wasn't passing flying colors, he was getting about 65% on average, but he got his ATA score that he needed to get into science at Melbourne, and then he majored in mathematics there. Okay, so that particular student showed tenacity the entire 2 years of learning something he didn't learn before. You guys are technically at an advantage. I assume most of you know how to do some of that. And if you don't, there's one student that you can look up to. Here we go. So how do we do this one? Hopefully at this point, using cross method you're familiar with, or you practice the worksheet. Find the factors of x squared. Number in front of x squared is 1, so it's just 1 and 1. Factors of 8, you've got 1 and 8, 2 and 4. And remember how I told you yesterday that the one that I normally teach my students 80% of the time it will work? Pick the one with the least distance between each other. So I picked 2 and 4 to start off with. Okay? So here I would have done 1x, because that's how you get the 1x squared. That's where the 1 and 1 comes from. And then I would pick 2 and 4. 2, 4, here we go. Let's use our cross method. The nice thing about monic trinomials is that because when it's 1 and 1, it actually doesn't matter how you pair it. will always be the same. Whether you do 2 with this one or 2 with this one, it's the same answer. So do a cross method. That gives you 2x. 1x times 2 gives you 2x. 1x times 4 gives you 4x. And your goal is to get negative 6x. Right there. This is what you want to get. 2x and 4x. How do I get a negative 6? What would you need? Anthony? Good. To get a negative 2 and a negative 4, well, this 2 here had to be a negative, and that 4 had to be a negative. Now you write in your bracket. So eventually, you don't have to do the working out I'm showing you, but this is the beginning stages if you haven't mastered the skill yet. So the 1x and 1x came from the very first term, so I write in 1x, 1x. You see, if you expand the brackets, 1x times 1x gives you 1x squared. That's what I wanted. What did I pair the 1x with? I paired with a negative 4. So that means 1x with 1x is 1x squared, but then 1x with, and I need a negative 4 there. What about the other 1x? I paired it with a negative 2. So that means over here, this needs to be a negative 2 to multiply with the 1x that I've paired. And then finally, negative 2 with a negative 4. Does that give you positive 8? Yes, it does. See that? So this would be the preliminary stages of factorizing. So that's called monic trinomials. It's easier because it's just 1 and 1. So every time you see the number in front of x squared, there's no number. This is much easier to do. Okay, so your worksheet, the one that I gave to you yesterday, 3a and b, most of it is monic trinomials, so it's easy. 3c, you start working with more non-monic trinomials. Okay, so that means the number is not 1. So here, same drill. 4, factors of 4 is 1 and 4, but you could also have 2 and 2. Whereas over here, you've got 1 and 3. Let's do it again. Let's practice the same thing. So to get this 4x squared, I needed either a 1x times a 4x or 2x times a 2x. The ones I would pick, the ones with the least distance. Now, only 80% of the time this works, okay? Doesn't work all the time. So let's try it. I've got 2x, 2x. 2x and 2x makes that 4x squared. What am I pairing with? Well, there's only 1 and 3 here. So here we go. We write 1, 3. Cross method. Let's go. I need to get that negative 8. So I could pair the 2x with a 3 or 2x with a 1. Let's see what I'll do over here. I might try 2x with a 3. So that gives me 6x. And then 2x with a 1. That gives me 1x. Doesn't look like I'm going to get my negative 8. 1 and 6 can't get to 8. So that means this pairing doesn't work. So hence 80% of the time it works. Did I do something wrong? No. Okay. So then what do you do? That means... Oh, what am I doing? My bad. I did do something wrong. 2x times 1 is 2x. Actually, it does give you the 8. And how would I get my 8? It would have to be a negative 2 and a negative 8, which means that this has to be a negative 1 and negative 3. Okay, so 2x times negative 1 gives you negative 2x. 2x times negative 3 gives you negative 6x. Let's fill it in. First thing I fill in is the first term. So that 4x squared was made of 2x times 2x. So here we go. 2x times 2x. There we go. We got the first term. That's my 4x squared done. What did I pair the 2x with? I paired it with the negative 3. So the negative 3 has to go here. The other 2x was paired with a negative 1. That's my negative 1. And then check your last term. Is this true? Does negative 1 times negative 3 give you positive 3? Yes, it does. So you've got all 3 terms to work out. That would be factorizing. Now, that was just factorizing. I haven't actually solved anything yet. You see in both scenarios, in these 2 examples, we still have not finished. Remember, it's equal to 0. It's equal to 0. So this is meant to equal to 0, and this is meant to equal to 0. This is where you apply null factor law. Something times something equals 0. Something times something equals 0. Use what I just taught you before. Let's solve. X minus 2 needs to equal to 0. Adding 2 on both sides, you have one possible answer. X could equal to 2. This one, same thing. Maybe x minus 4 needs to equal to 0. And you can see adding 4 on both sides, you get x equals 4. So for this question, the answer is x equals 2 or x equals 4. So you have to factorize, then solve. Same thing over here. You got something times something has to equal to 0, so one of these brackets need to result in a 0. So what you're saying is 2x minus 1 needs to equal to 0. If that's true, what would x have to be? Again, balance the equation, add 1 on both sides. You get 2x is equal to 1. Divide both sides by 2, and you get half. Okay, so that's one last answer. And then finally do the same thing on this side. This is 2x minus 3 needs to equal to 0. Add 3 on both sides. And divide 2 on both sides. So this last example that I just did with you, that one right there, that's what I'm interested in seeing. So when I go through your homework exercise 3C, what I do is I scan through to get to this point. I scan through to see how did you go from here to here, and how did you go from here to here, because it tells me a lot about you. So if you're skipping steps, I also know it's one, you don't know it, or you know it so well that you can skip steps. It's one or the other. Okay, so if you're using these techniques, then I know you're a beginner. If you went from here to here to here without any extra steps in between, then it must mean either one, you cheated, or two, you definitely know the maths really well, so hence you skipped a lot of steps. It's one of those, yeah? But I get a sense of what you do. And if you leave it blank, then I know you can't do this, but then you can do that, and I know you can do cross method, but only with one. See what I mean? So each of your working and what you choose in your questions for your exercises tells me a lot about you, and that's how I build my evidence about you. Okay? I'm going to stop there. That's part of my video. That's pretty much the essence of what you need to know for exercise 3C. The next two questions, I'm going to write the solutions to, but they're just applying. So you can't do the applying unless you get this bit. You need to master these skills before you look at the next one. Cool? All right, I'm going to stop the video there, and you've got not much time left.